have posted basics of partial differentiation in the Google Classroom. I hope everyone got that notes.
Yes, sir.
Hello.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Do you have any doubts in the basics of partial differentiation? Hello.
No, sir, no doubts.
No
Please
doubts.
kindly respond because I'm now moving on to the next topic in partial differentiation chapter. So if you have any doubts, any clarification needed of the basics of partial differentiation, you can please let me know.
Sir, one doubt. If dou inside partial differential equation, if we multiply function and another partial derivative,
Can
then
you
it
please be
will
louder?
is, when we multiply a normal function and partial derivative, we then find its partial derivative. Is it second order derivative?
I'm not getting your question. Hello.
Sir, when we multiply normal function
No,
and
your audio is very
partial
low.
derivative,
Your audio is very low.
now can you hear me, sir?
Yeah.
Sir, when we multiply a normal function and partial derivative, then find
Okay.
it partial derivative. Is it second order partial derivative?
Can you give some examples?
Like dou by dou r of r square into dou by dou r. Like that.
R square into
Dou by dou r.
okay dou by dou R.
And there u should be there, sir. Dou u by dou r like that.
Okay.
And partially differentiate it with respect to r.
What is U?
U is a function of r.
Okay, then you are supposed to use product rule for this. If U is a function of R,
Yes, sir. Is it a second order derivative? I'm asking that, sir.
no, it is not second order derivative. How can you say? It is first order derivative only.
Yes, sir.
See, any product squaring of squaring of first order will never become a second order derivative unless you differentiate it again. Unless you differentiate this function again, you won't get the higher order derivatives. No product or squaring of any function will not make it
Sir,
as a
if we
second order
differentiate,
or higher order terms.
sir, if we differentiate this only again with respect to r.
If you give U what is U, then I will tell you how I can differentiate this. If you are supposed to give a specific function for U now, then I can differentiate it.
Okay, sir.
Okay. I hope everybody knows how to when to use partial differentiation. Hello. When will we come across partial
Yes, sir.
differentiation?
Factors. When there are two or more variables.
Sir, when the function is equal
When we
to
have more than one independent variable, you are not supposed to say only variables. It has to be more than one independent variable. Here, x as well as y, they are considered to be the independent variable. If z is dependent on more than one independent variable, then it is considered to be, then you will come across partial differentiation, right? I'm waiting for your response.
Yes, sir.
Yes, sir.
yes,
Yes,
sir.
understood,
Yes,
sir.
sir.
Yeah. Okay. Now let me take the mathematical definition of dou z by dou x. Do you remember I have written in terms of limit delta x tending to 0 f of x plus delta x comma y minus f of x comma y divided by delta x. Is it correct?
Yes, sir.
Yes.
What is this expression indicating us? Here you are changing x, you are allowing x to vary, whereas y is kept as a
Constant.
constant. When you are differentiating with
Constant.
respect to one independent variable, other independent variable should be treated as constant. This is what you are following. Please remember that this definition, the mathematical way of expressing dou z by dou x. There should be change in x and y should be kept as a constant. Okay? Is it fine?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Now, I will take, please try to recall from if you have dy by dx is equals to f dash of x, then the differential dy, can we write that as f dash of x into dx,
Yes, sir.
Yes.
where we call
Yeah.
this dy as the differential. Fine. Now, how exactly the differential looks in partial differentiation, that we'll see. Suppose if I take z is equals to f of x comma y as a function of two variables, now I will try to give some increment to x. I will change x to delta x, that is I will give increment to x. I will give increment to y also. What will happen to z? Will it remain as same z, or can we expect some changes in z too?
Will change, sir.
Change. I will just write that change as delta z. That is z plus delta z. For example, if you have area of the rectangle, when I change the length, then you can expect some changes in area. When you change breadth, then also there will be change. If I change both, then also we can expect changes in the area, right?
Yes, sir.
Yes.
Yes, sir.
Please
Yes,
kindly
sir.
respond. I will take the subtraction of equation number 1 from 2. Equation number 2 minus 1 will be considered. What happens? I will get z plus delta z from equation number 2 and minus z from equation number 1. The right hand side quantity will become, what is the right hand side quantity? It is f of x plus delta x comma y plus delta y minus f of x comma y. Can we simplify the left hand side part?
So become delta z
Yes,
equal.
sir.
Zero or just
Delta Z
delta
will
z?
be left.
Will it become delta z or 0?
Delta
Z.
Z, sir.
Delta z. Okay, good. So here I will take f of x plus delta x comma y plus delta y as it is. I will just change something here like x comma y plus delta y. I'm just trying to manipulate here. I will add and subtract this term. The first and fourth term will be kept as it is, whereas these two terms are the same
Yes, sir.
but with opposite sign, right? If I just cancel them, are you going to get back the previous expression?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now, I will try to rearrange this f of x plus delta x comma y plus delta y minus f of x comma y plus delta y. This is one term. And the next term, I will just write it here, plus f of x
Sir, I didn't
comma,
understand how you got del z equal to this expression.
I didn't get your question. How did I get?
Del z, equal to f of x plus del x plus y plus del y minus f of x comma y plus del y.
These two terms I have just added here. second and third term I have just added and subtracted. Okay. Here I have considered first equation as z is equals to f of x comma y. Then the second one, I just got that second equation by giving increment to x as well as y. When there is a change in x, change in y, we can expect some changes in z. That change in z, I have written it as z plus delta z here.
Yes, sir.
Fine. I have
Yeah.
subtracted equation number 1 from 2, or 2 equation number 2 minus 1 if you consider. The left hand side quantity is z plus delta z minus z.
Yes, sir.
And right hand side of this equation number 2 I have written as it is. Right hand side of equation number 1, that also I have written as it is. In the next
Yes.
step, I just added and subtracted this term.
Oh, okay. Yes, sir. Understood.
Okay. Next, what I will do here is, I will just divide this by delta x and I will multiply delta x. Is it still going to be the same equation as the previous one? Because you can cancel delta x, right?
Yes, sir.
Yes, sir.
Same.
Okay.
Yes, sir.
Here, in this expression, I will divide by delta y and multiply by delta y. Does it indicate something? I will just highlight this term. Okay. Will it indicate something? Can you just recollect from the definition of partial differentiation? Okay, I will just show you the definition again.
Do you by do
Here,
x?
here, just a minute. When you are considering dou z by dou x, you are saying that f of x plus delta x comma y minus f of x comma y. When you are differentiating with respect to x, y will be kept as constant, whereas x will be allowed to vary. But there is a limit here. Divided by delta x is also there. Is it something similar to that?
Sir, it's partial derivative.
Okay, when can it become partial derivative? If I just take limit delta z tending to 0 here, limit delta x tending to 0, limit delta y tending to 0. Fine. Is it okay?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
What will be the first term? First term in the right hand side. Does it indicate the partial derivative of the function with respect to x? Because you just observe here. Hello, am I audible properly?
Yes,
Yes.
sir.
Yes, sir.
Can you just see
Yes,
this
sir.
term y plus delta y and y plus delta y? The meaning is y is not changing. Do you agree?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Can we say x is varying now?
Yes, sir.
Yes. And there
Yes,
is a
sir.
limit delta x tending to 0 divided by delta x is also there. Can I say that is dou z by dou x? That is the
Yes.
partial derivative of the function with respect to x.
Yes, sir.
Yes, sir.
Yes, sir.
What happens to this term?
Partial
As limit
derivative.
delta x tending to 0, will it go to 0? Can I say it just becomes dx?
Yes, sir.
Yes, sir.
Oh, sir.
dx.
Only one answer, yes. Only one answer is yes. Why it is? See, when you derive
Del Z.
dy by dx, you are just going to observe this with delta x tending to 0, and this concept is also analyzed as delta x tending to 0. This you won't write it as 0 by 0 form. When you're changing like the small change in y or small change in x, this you are going to write it as dy by dx, right?
Yes.
Yes, sir.
Yes, sir.
The
Yes, sir.
same thing I have done it here. the first term just became dou z by dou x into dx. And can you see the similar things in the second term also? Limit delta y tending to 0, y is varying, but x is kept as a constant. Can I say it is
Del Z upon del Y.
Dou z
dou
by
z
dou
by dou y into
Into dou Y. Dou Y.
dou delta
dy or del y?
dy.
dy. What should happen to the left hand side term as limit delta z tending to 0 delta z?
dz.
This becomes
Yes, sir.
dz. Can you just see, just a few minutes ago, I explained the differential concept in ordinary derivative. It was dy is equals to f dash of x into dx. Now, can we say it is also similar to your ordinary derivative here, that dz is equals to dou z by dou x. Dou z by dou x is indicating fx, partial derivative. Here also it is partial derivative multiplied with dx and multiplied with dy. This we call it as just the differential or total differential or exact differential. Anything can be asked in quiz, like find the differential or find the total differential or find the exact differential. All those words are same. You just have to use this thing. Dz is equals to dou z by dou x multiplied by dx plus dou z by dou y into dy. Nothing. When they give z as a function of x and y, you just have to find out partial derivative of that z with respect to x and y, and dx dy should be kept as it is. Need not to write anything for dx dy. Just write dou z by dou x, whatever you get, that multiplied by dx, dou z by dou y multiplied by dy. That's all. Any confusions?
So one doubt, sir.
Yeah, please.
So I understood the splitting it into two parts and taking limits of both of them with respect to dou x and dou y. But what I didn't understand is when it's the same equation for z, right? How did we multiply and divide dou x into dou x and divided by dou x only for one part and not for the entire equation?
So you're just observing these changes with respect to x only.
Yes, sir. But from the previous step, it's the same equation that we split it into
Yeah,
two.
exactly. See,
So how did we multiply and divide
just
only
a
for
minute, just
one
a
part?
minute, just a minute,
Yes.
just a minute. See, if these two quantities are different, then there would have been different case. See here, I am just multiplying this by 2 and dividing it by 2. Here, this I can multiply it by 3 and divide it by 3. Do you agree? Can we multiply and divide that by different numbers for different terms
Sir.
here?
Yes, sir.
Same thing, that delta x, is it going to be a numerical value? Because you are saying it is a
Yes, sir.
change. Hello? Change in x direction or
Yes,
change
sir.
in y direction, is it going to be a numerical value?
Yes, sir.
Then in that case, can I multiply or divide by these things or not? Is it possible?
Yes, sir. Understood, sir.
Okay.
Yeah, got it.
But this
Thank you.
delta x, see what we are saying is throughout this equation, I am not changing anything with respect to x only. Z is changing with respect to x as well as y. So here that delta x is tending to 0 is considered only because here there is a change with respect to x, right? Here, x plus delta x, x. Y is not changing. Hello? Okay. Whereas here, x is not
Yes, sir.
changing,
I get you.
y is varying now. Am I correct?
Yes, sir.
Therefore, I am allowing not only x, I am also allowing z to vary, that is delta z tending to 0, delta x tending to 0, delta y tending to 0. Therefore, I have got this expression.
Understood, sir.
It's good.
Thank you.
Actually, like I asked something about this derivative. What is that? Derivative of total differential or exact differential, because sometimes we will not get that idea how exactly we can derive it simply by taking dy is equal to f dash of dx, we can write dz is equals to f dash of x comma y into dx plus g dash of x comma y into dx. But dx, how do you take it for two terms? So that is the thing which is troubling, that makes us to derive this thing now. Okay.
So could you give any examples on this? Like,
Yeah, definitely I will solve few problems. But before that, I have to introduce few more things. Then only I will take examples. If you want, you can just take, if you take this example, z is equals to x square plus y square. In this case, dz will become dou z by dou x, which is 2x into dx plus 2y into dy. The simple thing is x dx plus y dy will be there. This thing can be written as dz by 2 for this function.
Yes, sir.
You will come across this thing again in your higher semester courses, how they are going to use this x dx plus y dy or x square dx plus y square dy, something like that. Then you will come to know the application of this total differential. Or sometimes when you are taking the approximations, especially finding out some errors,
yes, sir.
in those cases you can make use of this part, total differentials. I will give such examples later. But here, when you see from the problem's point of view, if you have some function z as a function of x and y, you just have to differentiate with respect to x, differentiate with respect to y, and then multiply the differentials.
Yes, sir. Understood.
Okay. Now, I hope you have learned something called chain rule of differentiation.
Yes,
For
sir.
example,
sir.
if y is a function of x, and in turn, x is a function of t,
T.
how do you differentiate this? If I have to get the differentiation of y, will it be with respect to t?
T.
Yes or no?
Yes, sir.
Yes, sir.
D.
Firstly, you will find out dy by dx. Then again,
Dx
x will be
upon
differentiated with respect to
dt.
T.
t. Are you going to call this as chain rule?
Yes, sir.
For
Yes, sir.
example, you take this
Yes,
y
sir.
is equal to x cube, and x I will take it as a simple function e to the power of 2t. In this case, first you find out dy by dx, which will be 3x square, and dx by dt, that becomes 2 e to the power of 2t.
Sir.
On simplification, it is 6x square. What can we write for x square?
E2.
Is it e to the power of 4t?
Yes, sir.
Yes, sir.
X
Yes,
is
sir.
e power 2t. Square of this will become e power 4t. Therefore, on simplification, it becomes 6 e to the power of 60, right?
Yes, sir.
Straight away also you can do it by substituting here x as e to the power of 2t, and cube of that will become e power 60, which on differentiation gives you 6 times e power 60 only. But the rule which we are saying here is that is a chain rule of differentiation. The same thing which we can follow in partial differentiation. For example, z is a function of x and y. X and y in turn, like x is a function of t, y is a function of t.
GT.
What happens to the relation? Have you heard about something called transitivity? A is related to B,
Yes,
B is
sir.
related
That
to C.
functions
Can I
chapter
say there
in 12th
exists a
grade I
relation
had.
from A to C?
Yes, sir.
Okay.
Yes, sir.
Just observe here, Z is a function of how many variables?
Two variable.
Previous one. Here. Z is a function of how many variables?
X
Two.
and
Two
Y.
variables.
Two variables, X and Y. In turn, they dependent on how many variable?
Two also.
1.
One.
One
Can I say there
variable.
exists a relation from Z to T now?
Yes,
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 sir.
sir.
Yes, sir.
Okay. Any questions? Somebody asked something.
So could you scroll up a little?
Here, I have taken z as a
Yes,
function
sir.
of x and y. X and y, they in turn dependent on only one variable t. Right? Now, if z is dependent on only one variable, are you going to come across ordinary derivative or partial derivative? This z is dependent only on t now. Are you going to use ordinary derivative or partial derivative?
Ordinary.
Ordinary.
Can I say it is dz by dt?
Yes, sir.
But z is firstly dependent on how many variables?
Two
Variable.
variables.
So should I have a partial derivative here? Dou z by dou x as well as dou z
Del
by
X.
dou y. But in turn, x is dependent on a single variable t. Therefore, I should have a derivative
So del X upon del T.
dx,
dx.
not del x. It should be dx because ordinary derivative should be in picture now. Because x is dependent on only one variable, right?
Yes, sir.
Yes, sir.
The next one here it is dy by
Y upon dt.
dt, right? Can you write? Can you just see the total differential here?
Yes, sir. This is the same thing we wrote.
Yes, sir.
It is not the same thing. It is called total differential. And if I take that z is a function of x and y, and x and y in turn, if they're dependent on any independent variable, then that quantity will be just act as a derivative. Dz by dt, dou z by dou x, dx by dt will be there, and dy by dt will be there, right?
Yes, sir.
The previous one, which I just showed now, is considered to be total differential, whereas this is total derivative. Can I say that dz by dt as derivative? Derivative ಅಂತ ಹೇಳ್ಬೋದಾ ಅದನ್ನ? Can we say that as a derivative?
Yes,
Do
sir.
you have a derivative there,
Yes,
dz
sir.
by dt? Yes.
So this is when the z is dependent on two other variables.
Z is
right?
dependent. If z is dependent on only x and y, then I can frame total differential.
Okay, sir.
But in turn, x and y, if it is dependent on some other variable t, then I can form a chain rule of differentiation. This is called chain rule, and we have given a name total derivative. Does it look like your chain rule only? Z is, sorry, I explained this. Y is a function of x, and x in turn is a function of t. Have I got this? But now I have two variables. Z is a function of x and y in turn function of t. Can we have ordinary derivative as well as partial derivative here? Why partial derivatives here?
Yes, sir.
There are two independent variables.
Okay, let me show it you with the graph here. One dependent variable is there. It is dependent on two independent variable, and in turn this x and y, they dependent on
T.
t. This will act as intermediate variables.
So,
Since z is function of x and y, can we frame dou z by dou x here in dou z by dou y?
Yes, sir.
Okay, but x is dependent on how many variable now here?
One variable.
One variable. Therefore, I will get dx by dt, and even y is dependent on how
One
many
variable. T.
So you just write this as one term. That's what I have written here. Dou z by dou x into dx by dt. Am I correct?
yes, sir.
Yes, sir.
And this part. is the
Sir,
second
in
term.
total differential, the two variables x and y were not dependent on another
Exactly.
variable.
They were not dependent on anything else. We just considered z as a function of x and y. That's all.
Yes, sir.
After taking dou z by dou x, why don't we again take dou x by dou t? Why do we take dx by dt?
Why?
Sir, after dou z by dou x, why don't we take dou x by dou t? Why do we take dx by dt instead?
That's what my question is. When are you going to use ordinary derivative and when are you going to use partial derivative? If you understand that, then only you can say why exactly I have written dx by dt and dou z by dou x. See, if you have a case like y is equals to f of x, are you going to write dou y by dou x or dy by dx?
dy by
dy by
dx.
dx.
Why you are writing dy by dx? Because y is dependent only on.
One variable.
One
Yeah,
variable.
Yeah.
one
Okay.
variable.
Omisha, can you see here? X is dependent only on
dt.
t. Now you tell me, should I write dou x by dou t or dx by dt?
dx by dt. Oh, so
Hmm?
we take dx by dt.
Okay.
So we take partial derivative when the other variable is also dependent on some other
When
variable.
you have more than one independent variable, you will come across partial differentiation. This is the first thing you should have in your mind. When are you going to use partial differentiation? Only when you have more than one independent variable. Otherwise, you have to use ordinary derivative only.
Okay, sir.
Okay. Have you understood what exactly is total derivative? Similar to total differential only, in turn, x and y, they are going to depend on one more variable, right?
Yes, sir.
Hello, sir.
Yeah.
Yes, sir.
Yes, sir.
Sir. So what is the difference between a partially derivative and ordinary derivative?
Now you have to tell, you have to answer. After doing 6 or 7 classes on partial differentiation, you are asking me.
This is my
Just
first
now,
class.
I have explained why are you supposed to use ordinary derivative and why you are supposed to use partial derivative.
Sir, I think he's a new student, sir. I think he
Yes,
joined
sir. I
only
think he
today.
just joined
Sure.
today.
Uh, then it is very difficult. Like, see, if you have more than, say, try for time being, you can just analyze it like analyze like this. For first part of partial differentiation, we are going to concentrate on more than one independent variable. If you have function like y is equals to f of x, we will just follow
Sir.
one differentiation process, which we call it as dy by dx, which gives us f dash of x. Then if you have f of x comma y, for example, u is equals to x square plus 7xy plus sine of xy, something like this. In this case, u is dependent on x as well as y. You have two variables. In this case, you are supposed to use the differentiation dou u by dou x as well as dou u by dou y, that we call it as partial differentiation. Hello, may I know your name?
Abhinay
New
Kumar,
student.
sir.
Huh?
Abhinay Kumar.
Abhinay Kumar. Are you familiar with differentiation process?
Yes, sir.
So if you are familiar with differentiation, then this partial differentiation won't be very difficult because all the rules of differentiation which you are following for a single variable is applicable for partial differentiation also. Only thing, when you are differentiating with respect to one variable, treat the other variables as constant. Just like 7x when you are differentiating here, for example, you have something like x square plus 7x plus 5. In order to get dy by dx, I will just write 2x plus 7. I will treat
Seven.
this 5 as constant. In a similar way, here, if you are differentiating this function with respect to x, treat y as constant.
Yes, sir.
If you are differentiating with respect to y, treat x as constant.
Constant.
Okay. Now, I will just move on to the extension of the total derivative. So far, I have considered z is a function of x and y, and x is a function of t. Now, what I will do is x, I will take it as a function of 2 more variables, and y is also a function of 2 more variables. Can we still expect ordinary derivative now?
So
No,
could you
sir.
repeat what you said like just now?
Sir.
Z is dependent on x and y.
And y.
Now x is also dependent on two more variables, u and v. Y is also dependent on 2 more variables, u and v. Can we get dou z by dou x? Or can we get
Yes, sir.
ordinary derivative? That is the first thing. Can we get ordinary derivative?
No, sir.
No,
No, sir,
sir.
you'll get
No, sir.
partial.
Yes, sir.
Z is dependent
No,
on
sir.
x and y. In
Y.
turn, x and y, they dependent on
U and
U
v.
and V.
u and v. So again, this will act as intermediate variable.
Intermediate variable.
Okay. Use the transitivity. Z is dependent on x and y. X and y, in turn, they depend on u and v.
And v.
Can I say there exists a relation for z and v? Z from u to v?
Yes, sir.
Yes, sir.
Z
Yes, sir.
is connected with u and v here. So when z is dependent on 2 independent variables, can I say I will get dou z by dou u as well as dou z by dou v? Is it possible
Yes,
to
sir.
find out both partial
Yes, sir.
derivatives?
Yes, sir.
Respond ಮಾಡಬೇಕು. You should respond.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir,
Yes.
we can get.
Okay. But firstly, z is function of
Upon
Son
Yes,
of-
and Y.
x and y.
X
Therefore,
and
we
y.
can form a partial derivative of z with respect to x and y. In turn, x is dependent on u, and now we are differentiating with respect to u. Therefore, x has to be differentiated with respect to u. Even y is function of u and v, and since we are just differentiating y with respect to u, I will write dou u by dou y. This is how you are supposed to write the composite function or the chain rule of differentiation for functions of 2 variables. Z is function of 2 variables, and in turn x and y are dependent on 2 more variables. In this case, you are supposed to write like this. Similarly, for the next one, z is function of x as well as y in the beginning. Therefore, we will write dou z by dou x. Now we are differentiating with respect to v. Therefore,
X
x
by
will
dou
be differentiated with respect to v, and y will be differentiated with respect to v. Fine.
Yes, sir.
Yes, sir.
Started with just total differential. Next, we explored something on total derivative. And now we have a composite function like z is dependent on 2 variables, and they in turn dependent on 2 more variables, or it can be for 3 variables also. We can write it, the extension of this. I will just try to familiarize these things. For example, u is dependent on r and theta, and r and theta in turn, if they dependent on m and n, can we form 2 partial derivatives here?
Yes, sir.
Yeah, what
Yes,
are
sir.
those
Yes, sir.
partial derivatives?
Yes, sir.
du by
Dou u by
dou
Dou
u
u
by
by
dou
dou m
r
and dou u by
dou u by
And
dou n.
dou u by dou n.
dou n, because u is connected with m and n now. Firstly, u is dependent on r
Dou u
as well as
theta.
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 Since we are differentiating with respect to the variable m now, this r has to be differentiated with respect to m, and theta has to be differentiated with respect to M. Okay. Now the second equation, it can be written as dou u by dou r, and r has to be differentiated with respect to
N.
n. Dou u by dou theta, and theta has to be differentiated with respect to
N.
n only. Okay. Now let me take few more examples.
Why the student sir scroll down now?
Hello? Any questions? Now let us take z is a function of a and b. How do I write total differential for this? Total differential. Am I audible?
Yes, sir,
Yes.
audible.
Okay. My
Yes.
question is, for z is equals to f of a comma b, how do you write total differential?
dz is equal to
So dz is equal
dz
to
is equals to
dou z
dou
by
z
dou
by
x
dou a by
dou
dou
z
a
by a
Dou A
into
dou
d
a by dou
plus
dou z by
dou Z by dou B
dou b
into
into
db.
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 Done. Okay. Now let me take u is a function of r and s. R and s in turn they depend on x. What will you do? Are you going to construct composite function of two variables, that is two function dependent on two function, or two functions dependent on one function?
the
two
two
functions
functions
Dependent
depend
on
on one function.
Now what type of derivative you are going to get here?
total
partial and
Total derivative. Are you going to
Total
get
derivative.
dou u by dou x or du by dx?
du by dx.
U by dx.
dx.
Okay.
du by dx.
What happens to the right hand side term?
Dou U by dou R
dou u
dou
by
u
Dou u by dou r,
dou r
into
by dou x
dou r
dou r by dou x or dr by dx?
R by
dr
dx
dr by dx.
dr by dx.
Next,
plus dou U by dou S
by
into
dou
D
s
ds by
dx
dx.
by
dx
dx
by dx.
the best thing is you just write some tree diagram like this. Z is dependent on, sorry, not Z here, U. U is dependent on
R and S.
R and S. R and S in turn they depend on
X.
X. So if you connect a relation from U to X, U is dependent on one variable. Therefore, you will get ordinary derivative in the left hand side. And in
Yes.
turn, U is dependent on two more variables, that is the intermediate variable. Therefore, you are forming partial derivative here, dou u by dou r and dou u by dou s. Am I correct?
yes sir
But r is
Yes.
dependent only on x. Therefore, you will get dr by dx here and ds by dx here. That's the formula. Quite easy. Or any confusion still?
No, sir.
No, sir.
understood
Please respond.
No, sir.
No. Okay.
No, sir.
Next, if I take h as a function of r and s, r and s in turn they depend on m and n.
And then
How do you get the how do you get the equations here? Are you going to get two equations here?
yes sir
Equation.
Dou h by
Dou h by
dou
dou
n
dou h by dou m and dou h by dou
dou
n.
x by dou n
okay. Can you tell the first one? What will happen?
dou x by dou
Dou r by dou h or dou h by dou?
dou x by
H
dou
by
r
dou R, sir.
Dou h by dou
into
r.
Then
dou r by dou n
Into dou R by dou M plus
because m, you take this variable to the numerator and write whatever the variable which you are differentiating here. Next, dou h by
dou s
dou S plus dou S
in
by dou N.
dou
M.
s by dou n mm
m or n.
M, sir.
When you are differentiating with respect to m, you are supposed to write m only. Next, dou h by dou r again,
OS.
and then
dou s.
r has to be differentiated with respect to
n
n. H by dou s And
into
s
dou
should be
I by
differentiated with
dou X.
respect to
N.
Twice by dou N.
N, sir.
these terms should be same. You can see that I have marked here. This is same. This is same. And here you are just changing the variables. Here m, n, m, and this is n here. That's the change. So I hope you have understood something to frame the equations for a composite function here.
Yes.
Yes, sir.
Yes.
Okay.
Yes, sir.
Then I will just move on to the known thing, implicit function. Have you heard about it?
Yes, sir.
Yes, sir.
Okay.
f of x,
Can
comma y
somebody
is
tell
equal
me
to
what
0.
exactly is that implicit function is?
Of x, comma y equal to 0.
Like in a function.
Okay. One person told that f of x comma y is equal to 0 or constant
Uh,
c. Anything
When
can be
it's
written.
related to only one variable,
Like we
that's
cannot
implicit.
express one variable
Like,
with respect to
yeah,
another.
Okay. If you have equation y is equal to f of x, this we call something like explicit form. The reason is you can express y completely in terms of x. Can you see? Y is completely expressed in terms of x, right? If I take this simple example itself, x square plus y square is equals to some 4. This represents the circle equation with center 0, 0 and radius 2. This is considered to be an implicit function. The reason is when you express y, it will be 4 minus x square under root. It has to be written like plus or minus. If you don't write this, if you consider with plus sign, it represents upper half of the circle, or if you write
Lower half.
negative sign, it represents lower half of the circle. Am I correct?
Yes, sir.
Yes.
In those cases, like for example, x cube plus cos of xy plus 3x square y is equal to 0. How do you differentiate this? Can I say this is also an implicit function, implicit function? Because y is not completely expressed in terms of x here, isn't it?
yes,
Yes,
sir.
sir.
Okay. In these cases, what they do is the differentiation of the function will be considered. That is, you take f is equals to x square plus y square minus 4. Or if you just differentiate this thing, it is dou f by dou x will be equated to 0. I'm not saying that dou f by dou x will become 0. The right hand side differentiation, it will be 0. This dou f by dou x, you can equate this to 0, right?
Yes, sir.
What I
Yes,
mean
sir.
is, if you have x square plus y square equal to 4, this can be written as x square plus y square minus 4 equated to 0. Now you can differentiate this and get df by dx or dy by dx. Fine.
Sir.
Correct, Adu? Can we equate this to 0?
Yes,
This
sir.
I'm going to use
Yes,
somewhere in the differentiation now. That is differentiation of implicit function. See, the problem can be made very easy for finding dy by dx using partial derivatives. I don't know how many of you know that. Some of you might have studied dy by dx, which can be expressed in terms of partial derivatives. That I will show you to now. Suppose if you have a implicit function, for example, u is dependent on x and y, they further depend on only x. Y is also function of x only. That's what we say it as implicit function, right?
Yes, sir.
Here y is also function of x. That's why f of x comma y, we call that as a implicit function. Now, if you write a total derivative rule for this, what will happen? Hello? Can we write total derivative rule for this? U is dependent on two variables, and in turn these two variables dependent on one variable. Can I say it is du by
dx.
dx is equals to dou u by dou x
X.
into
Dou x upon.
dx by dx, right?
Yes,
Yes.
sir. Yes, sir.
Next term dou u by dou y into dy by
dx.
dx. What about this term? Dx by dx, can I write it as 1?
Yes, sir.
Sir.
Okay. Dou u by dou y into dy by dx. Can I equate this to 0, because your implicit function can be equated to 0, right? After like differentiation of that.
Yes, sir.
Okay. Now, from this, can I get an expression for dy by dx? Is it equals to minus dou u by dou x divided by dou u by dou y?
Yes, sir.
This is the formula for finding dy by dx, ordinary derivative using partial derivative for an implicit function. I will just show you the example here. X cube plus y cube plus 3xy is equals to 0. This we can take it. Let us differentiate this using regular process. Can I say this is a implicit function?
Yes.
Okay. Can you just let me know how we can differentiate using ordinary process? It is 3x square plus
Y square
y square
Y
into
square dy by dx.
dy by dx plus 3x into dy by dx plus 3y is equal to 0, right?
Yes, sir.
Okay.
Yes, sir.
Others kindly respond.
Yes, sir.
Think about dy by dx now. Can we divide throughout by 3?
Yes, sir.
Yes, sir.
What are we going to get for dy by dx? Minus, is it
Y.
x square
Minus x
minus
square
y
minus y
Y by
divided by,
square by x.
is it x plus y square?
Yes, sir.
Yes, sir.
You please confirm me first. If it is correct, then I will show you how exactly I can do that using partial derivative. Is it correct
Sir,
here?
correct, sir.
Yes.
Okay. Now,
Yes.
according to partial derivative, dy by dx is equals to minus dou u by dou x divided by dou u by dou y. Just differentiate this partially with respect to x and let me know what is the answer. There is a negative sign. I will write it first. What is the differentiation of this partially with respect to x?
3x square plus 3y.
Sure.
Yes, sir.
Next, differentiation of that with respect to y partially.
3y square plus 3x.
Sorry, 3y.
Can you just compare these two results now? Are they same? If you remove 3 as common in the numerator and denominator and cancel it out, are you going to get the same answer?
Yes, sir.
Was it quite